Good morning, everybody. Welcome to this session. Before we get started, I'd like to thank the organizers for the invitation to come and speak here and introduce ESA Lab. Some of you may have heard about this, some of you may have not, but today with me is my colleague Rochelle Schneider, who is the operations engineer looking at work on Copernicus and Destiny ecosystem. She's also the honorary associate professor of climate and health and visiting professor to MWF. So lots of impressive titles there. I'm just an engineer. I've worked in industry in the UK for most of my career. A couple of years ago, I joined ESA. And today, between us, we'll cover ESA Lab and give you an introduction of what we do and maybe some of the plans that are kind of coming in the future. Before we jump into the definition and how we split ESA Lab, I thought it might be useful to talk about ESA Lab Net that you may have heard about. Labs are not about an R&D department, it's more of an innovation model. And since its conception, let's say in 2017, it's been incredibly successful. It's an area we kind of try and look at innovative ideas, fail them or kind of progress them quite rapidly as we can. And if commercially they have value in them, we'll try and kind of invest in them. The ESA Lab at Esdrin is basically focused on Earth observation, but I think it needs to grow and it needs to have other networks. So some of the member states in the future will have different versions of this. So this will be kind of part of the ESA commercialization department, and the Lab Net is going to be kind of managed by a joint unit at ESA Esdrin, but we'll coordinate the network and we'll look at how we can kind of transfer technologies, help each other, and kind of share resources and knowledge, and hopefully we can kind of help the ecosystem as we go along. The Lab itself is split into two very distinct departments or offices, as we call them. I work in the Invest office, and Rochelle was up to like recently was part of the Explore office, and she will tell you more about it shortly. But the two sides are slightly different. One is really looking at what are the innovative ideas, blue sky thinking, and kind of really rapidly trying to develop ideas. But where the second part is looking at is there a commercial need out there that we need to satisfy, and can we support industry by helping them and trying to kind of ease that pain, if you like. So I will talk about what we do at Invest Office and the program that we manage from there. So the program is called Investing in Industrial Innovation. It's a joint collaboration between ESA, the national delegation, and industry. But it's important to remember it's a industry-led initiative. So the idea here is both agencies are there to enable industry to progress and to address something that's in the market, rather than us mandating or dictating anything that needs to be done. So because of that, on the Earth observation domain, the domain is quite wide. So the areas that we can kind of support goes from the hardware side, space segment, ground segment, data segment, and within that, all of the subdivisions that naturally come with it. I won't go into too much details because I'm aware of time. This is just a bit of a show-off slide to show how many people and companies we have worked with. And as I said, it's been very successful and growing rapidly. So the idea is to try and find a way to really facilitate how we can kind of help our ecosystem and industry in Europe, and maybe compete with some of the larger economies around the world, maybe mainly US and China. Before I explain what we did with the UK, say a couple of years ago, I think I was looking into how we do space commercially within Europe. And when you compare that to US and China, it's shocking to see how much the level of private investment is lower in Europe than it is in America. And that is partly to do maybe with the culture, maybe with the way we perceive risk. And I think the agencies have a role to play here, because I think we've time and again we've seen, once the agencies or the kind of the national institutions step in and endorse and help industries, they find it much easier to raise capital. So we'd like to play a role in here and try and help industry to try and attract more investment, private investment into Europe, because I think the way things are happening in Europe is not because of lack of talent. There's plenty of talent here. I think we can do incredible things. So we'd like to be part of that. A couple of years ago, I won't go too far back, but in 23, when I first joined, we ran a joint call with the UK Space Agency to kind of look at UK companies within that can utilize InCube to try and help them to commercialize their product. We had about 5 applications came in. 2 of them we've kind of invested and signed in. One of them is a company called SuperSharp, that kind of looking into developing a thermal infrared imager. And another one is on the downstream side, is Messium, that's kind of looking at nitrogen estimator. Both of them are doing really well, and I'm kind of we're during the kind of implementation phase. And this year we decided to run it slightly differently. And some of you may have seen this during the Farnborough Air Show. We ran a call and gave it a theme. And the theme was innovation in public sector's use of Earth observation data. So I think UKSA, we were talking to Beth and others, that we realized there's a lot of need out there from the public sector. But I think it's very difficult to connect them with the commercial industrial side. I think something was mentioned earlier. Industry is finding it difficult to find basically place a contract with the public sector. So this idea here was to try and see if we can kind of help that and foster that relationship. So it was incredibly successful. We received about 17 applications, and some of which we are just about in the process of signing a contract. I'm hoping in the new year we'll sign the contract, so I'll be able to share the names and what we're about to do. Since that was really successful, we'd like to run another one in 2025, kind of unlike some of the other applications in Europe that we run for InCube. The ones in the UK run once a year, and we kind of announced the call. So the next year's one, I think I don't know much about it just yet. We need to have a conversation with the UKSA to see how we'll shape it. But I'm really excited to announce that next year. And this is more of a kind of a heads up. So if you guys, anybody interested or want to talk to us about it, please do come forward, and I'll be more than happy to talk to you about it. The idea here is just give you a quick flavor of the process. To me, it was very different to how ESA runs some of the other contracts, and that's why I think I really like working in this department. Is the idea is very rapid. So you have a idea pitch, you come to us and you pitch that within 15 minutes, and then you're kind of given a go ahead if the idea is commercially viable and you have a customer that kind of needs the product that you're developing. And then from that, we kind of work on a proposal that is written by the industry. So there's no statement of work defined from ESA, but it's from what industry needs to do. And then we've split that to 2 parts to kind of enable progression throughout the development of the contract. And then hopefully by the end of it, we'll be able to sign the contract. I won't dwell on this, but if you've got any questions, please do come and find me at the breaks, and I'll be happy to talk to you about it. This is just a graph to show how kind of we're operating, and basically since in the last few years, 5 of the companies we've had the privilege to support have commercially been incredibly successful. They're delivering already incredible data to the different departments of within ESA and also internationally. So kind of trying to show, once from a public side we can step in and help, I think that provides a bit of a programmatic and technical assurance for the private investors to step in and say, look, this idea is not as risky as you may think. We have an endorsement from the agencies, and there is some merit in that. And these are some of the examples that kind of have successfully raised additional extra funding after we've had the InCube development with us, and I'm hoping it's going to be more than that. So the idea here is basically normally once you invest 10% from the public side, you can probably see tenfold back from the private side to coming. So this is where we'd like to operate, and hopefully we can kind of raise the game within Europe. Hopefully I haven't overrun, but I'd like to hand over and invite Rochelle to talk about Explore Office and what we do there.
Thank you. Just checking if it's working. Okay, so now I bring you to the other side of PhilUp, which we call it the Explore Office, and in a minute you're going to understand why. So we worked a lot. This is Explore Office is an innovative lab at ESA where we try to bring the most recent technologies being created, the most transformative technologies to help us in Earth observation. So here you see pretty much the three main axes that we focused on, which is, of course, artificial intelligence and machine learning, quantum, edge computing, and other types of technologies that are not so known, but we are pushing them to explore the positive area of Earth observation. So for example, cognitive space, which I will show you in a second. So when we talked about AI, what exactly we are exploring in AI in the sense of in the PhilLab Explore side. So we know already that machine learning and AI are helping us to detect, classify different points, elements in the satellite image we use for super resolution, but we are also going forward and exploring onboard AI on satellites to help us in a variety of ways, transforming satellites in smart satellites, connecting different satellites with each other, or also prioritizing what will be downlink from the satellite images. So in the PhilLab Explore, we would like to collaborate with industry and academia. And here you see just a couple of examples of how we connect. We have our visiting researchers that can be both from industry and academia. We have our own postdocs, and also we have activities that can be co-funded by ESA. In this case, for example, PhD students and postdocs. We also have young graduate traineeships and national trainees. So a variety of opportunities for young people also come to ESA and then understand a bit better how we can use Earth observation for different topics. So we do this collaborative way, sharing mutual interest with companies and academia, but also we have our own funded opportunities. As I mentioned, we are pretty much interested in the transformative innovation. So we quite often issue tenders at ESA to exactly in this point, to collaborate and understanding how we can explore the foundation models, the chatbot, quantum for Earth observation is specific for this topic. We also have the Open Space Innovation Platform, is a different way to connect, is a light version. If you have an idea, you can come to us through the co-funding schemes of research, and then also suggest your idea to be co-funded by ESA and then also supported by PhilLab. So when I talked about these opportunities to collaborate with academia and industry, we have a portal where we initiated this collaboration, and then you can have more information through this web page, where if a PhD student would like to spend a period of time with us exploring a specific part of the PhD, or a postdoc is working in a specific project in a team and would like to come to us and understand a bit better how we are using machine learning models for Earth observation in overlap thematic, we can also support that. We also run challenges, and then here I invited you to explore what we just launched. Is called Grand Marathon, and in this case we run challenges, academic challenges and industry challenges, and you see here this is quite an interesting one because it's pushing us to develop more business oriented activity rather than just a researcher oriented. So as an example of activities, I would like to invite you to explore in the future some activities related to climate and health that we are soon issuing. And then this activity is actually led by ESA here in EXAT through the Actional Climate Information section. So I'm happy to tell you that the head of the section is here with us, Clement Abergel. If you wanted to know more about this activity, Clement or me can definitely talk more about it. So the idea is to demonstrate the benefits of using Earth observation and Earth observation-based data for climate change and health applications. And since we are talking about health applications, I would like to bring you to some ideas of what we have been doing in the PhilLab in terms of using AI and Earth observation for climate activities, and also collaborating with some organizations on this topic, and then focus on some activities that have someone from the UK involved, which we are very glad to share with you. So these are the only three that I'm going to show you. I will start with this one, which is UNICEF came to PhilLab and then ask us they would like to understand more how to use Earth observation data for their own activities. They were very interested in detecting dengue outbreaks in Latin America, and they would like to use more this information in that specific area. So I'm very happy to say that this project in the end started as a very pilot project, but it started to grow and then get a lot of attention and also a very positive feedback. This was selected in the end by UNESCO as one of the global top 100 AI solutions for SDGs. And then UNICEF also listed us as the best UNICEF researcher of the year. It has been also, UNICEF got an award from Wellcome Trust to continue exploring it. And if you would like to know more about it, you can check the Nature paper that we have with all the algorithms and data available for people to reuse it and replicate. Another activity is with GIGA. GIGA is an initiative between UNICEF and ITU to detect schools in the planet that do not have connectivity. Oh my gosh, in 2 minutes. So just to show you how we are exploring the use of Earth observation and AI for connecting schools and understanding which are the schools that do not have internet connection and electricity. And this, of course, is not possible only with Earth observation data, but is definitely, there is a value aggregated to include Earth observation connected with other geospatial information. So just happy to share with you that we have PhD students from 2 universities in the UK involved and doing the leading streams of these research questions that we would like to know where the schools are and what would be a possible school that we don't know that exists, but we also need our help. So finally, just to finish, this is an activity with LSHTM, is understanding how to reconstruct exposure of pollution using Earth observation data and correlating this with different cohorts of information, epidemiological information, and understanding where are the areas with a higher risk. And then here quickly, just to show you the connection of Earth observation data, climate models, to understand, to reconstruct this information together with the air quality monitors, and then to reconstruct this information over many years, and then trying to connect this later with some health organization guidelines and also UK policies on that. Super quick, last slide. Just invite you to join us if you are in this conference at EGU next year and in our sessions on health. Thank you.
Thank you very much. I will take one question. The thing that impresses me most about your talk there is the obvious and clear impacts of the work that you're doing, which is phenomenal to see and tells a really great story, like Chris was saying, about the impact of space on our everyday lives. So thank you for that. One question here. Hopefully you'll be able to stay around to speak for everyone else.
Catherine Courtney, Global Network on Sustainability in Space. 2 quick questions. One is the examples Rochelle gave, which are very inspirational. I'm not sure about the commercial market for those applications, and yet the INVEST conversation was all about demonstrating commercial viability. So could you explain a bit about the connection between those 2 things? And the other question is, this has all been focused on Earth observation, which many investors would say is already a crowded and fairly mature market. So are there other future markets that you're looking at, whether it's space traffic management or cislunar, people who have ideas that are 15 years from commercial viability, are they coming to you or can they come to you?
You want to do the explore bit or?
Yeah, I can start. The example of the infectious diseases forecasting is a very nice example connecting us. We start exploring and then in the end we invest this, we transform this into a service. So we have a startup that actually got in touch with us because they would like to initiate a service of an automated forecasting system for a specific country, and then they would like to use the algorithm that we developed as a starting point from that, and then they would like our support to how to materialize this into a business model.
I mean, I would add not everything that we do at Explore Office has to end up in the invest side. So that's the kind of the freedom, that's the idea in there that you can kind of do anything and look into it. And if there is potential, whether commercial or elsewhere, we will kind of try and foster that. Whereas on the invest side, excuse me, we are trying to look at something that has a bit of meat behind it. So it's not the very low TRL stuff. So we want to see that the idea is maybe at TRL 3 and it has a customer and it has a very well-defined requirements in that. And then we'll help the development. So it's not just the very start of it, but it's an initial kind of inception of an idea that kind of has a need out there that we can kind of help to bring it to fruition. For us, it's only looking at Earth observation. I think we will have to expand that through the FENet and look at different applications. But the idea really here is to try and commercially help Europe grow up and attract more investment, because it's not always about pushing technology forward, but it's actually understanding what are the requirements and needs out there that we can utilize from space applications to address them, and obviously start that ecosystem and start commercialization. I don't know if that answers the question.
Thank you very much. I'm afraid I'm going to have to hold the questions there. You are staying around, so there will be plenty of opportunity in the breaks to talk to
Of course, please
Pejman
do
and
find
Rochelle.
us and ask questions. Thank you.
Thank you very much again.
Yeah.